Hello class, this is part 2 of the lesson on secants, tangents, and angle measures. First, we're going to go over the last theorem of this section, which is theorem 9-13. And it says basically 3 different cases for lines intersecting on the exterior of the circle. So we could have 2 secants, we could have a secant and a tangent intersecting outside, and we could also have 2 tangents intersecting in the exterior of the circle. But regardless of what case it is that you're looking at, the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. So the difference here from what we have done previously in this same section is that it is not going to be about adding the intercepted arcs, but it will be about subtracting them. So I don't have any specific points here. So the only thing that I have is the angle created by the 2 intersecting lines. So this angle here, here, and here. And they're all labeled angle 1 because once again the relationship is going to be the same. So we're going to be able to describe the measure of angle 1 as being 1/2 the positive difference of the intercepted arcs. So if you want it to be more clear on that one, then it would have to be like the absolute value, right? Just to make sure that we have the positive. But all you have to really take care of is make sure that you do not end up with negative angles, okay? So let's take a look at this first case where we have 2 secants. So we have those 2 lines intersecting. They intersect this arc and this other arc over here. For a secant and a tangent, then we have this arc here that's intercepted and this other one over here. For the 2 tangents, we have this arc and this other arc. So in order to make sure that you end up with a positive difference, all you have to take care of is making sure that the first quantity that you put here comes from the largest arc. So in every case that I have here, that would be the one that I colored green. So let's just go ahead and call it the large arc. So we're going to take away the measure of the smaller arc. So regardless, like I said, of intersection where the lines intersect the circle, if we can just think of, okay, there's always going to be a large arc and a small arc being intercepted by the 2 lines, then if I want the positive difference, then first go ahead and write down what is the large arc, what's the measure of the small arc, and that way you will make sure that you have a positive difference. So here I have a few examples. I need to go ahead and find the value of x. First thing to notice, all of the lines intersect in the exterior of the circle. So here we have 2 secants, here we have 2 tangents, here we have a tangent and a secant line. So we're going to be applying the theorem, okay, where we're going to have that the measure of the angle, whatever that might be, is going to be equal to 1/2 the positive difference of the large arc minus the small arc. So here the value of x, that is going to be the angle that's formed by the 2 intersecting secant lines. So x is going to be equal to 1/2 the positive difference of the large and the small arc. So the small arc is going to be this one, and the large arc is going to be this one over here. So again, just to make sure that you have a positive difference, start with the large arc, so 120, and then the small arc is 50. So that means that the value of x is going to be equal to 1/2 120 minus 50, that is going to be 70. So that means that the value of x is going to be 35 degrees because that is an angle. For the second one, we have the 2 tangents. Okay, so we have that this angle here, angle A, intercepts the small arc which is this one over here. So from D all the way over to B. And then the large arc is from D all the way over to B. So a major arc. Let's go ahead and write that relationship, that angle A is going to be equal to 1/2 the positive difference of the large arc. So the large arc happens to be X minus the small arc, which is dB. We need to go ahead and figure out what is dB because I cannot have, more than two variables. So remember that the circle is always going to be 360 degrees. So another way to describe the measure of arc dB is to say that the measure is going to be equal to 360 minus this arc. So 360 minus X. Okay. So let's go ahead and rewrite that. So we have that the measure of angle A is going to be 25. This is equal to 1/2 the measure of X minus, once again, 360 minus X. Put that inside of parentheses, okay, because that's an expression. 360 minus X. And close the other parentheses too. So let's go ahead and first simplify what we have inside the parentheses. So we have 25 equals 1/2 X minus 360 minus X. Remember that you have to distribute this negative. So that means that we will end up with X minus 360 plus X. So 25 is equal to 1/2 X plus X. So 2X minus 360. We could go ahead and distribute the 1/2 since 2 goes into both 2 and 360 evenly. So we have that 25 is equal to X minus 180. And by adding 180 to both sides, I will end up with X being equal to 205. The third one over here, we have X is the measure of the angle. So we have X is equal to 1/2. And then inside the parentheses, we have the 78, that is going to be our small arc. And then the 6X minus 2, that is the major arc. Okay, so we have the major arc, 6X minus 2, and then minus the small arc, 78. So let's simplify the parentheses first. So we have 1/2 times 6X minus 80. Let's go ahead and distribute the 1/2 since the 2 goes into 6 and 80 evenly. So this is going to be equal to 3X minus 40. And this is X over here. So let's go ahead and bring the X over to the left. So we're going to subtract 3X from both sides. So I'm going to end up with negative 2X. And this is going to be equal to negative 40. And dividing by negative 2, we get that X is going to be equal to positive 20. So this is the measure of the angle. Okay, so here you have three different examples. Make sure that you review them, especially this one here, the second one, because of this negative that we have to distribute to that expression.